Last section of chapter 6, talking about similarity transformations. Now we talked about similar polygons, similar shapes. Basically, we said that they have to meet two conditions. One is their corresponding angles have to be congruent, and then their corresponding sides has to be, you can write that as an extended proportion, and they would have all the same scale factor, right? Now we're talking about similar figures, so not necessarily like a triangle. We talked about a triangle only needs certain parts, right? We went through those corollaries and theorems and stuff, uh, and postulates, but now we're talking about similar figures and how we can remove them, move them left, right, up, down. That's called a transformation. We can flip it about the x-axis or the y-axis, and we could rotate it about the origin, right? And then we have dilation, which we talked about the last section, 6.6. So now we're just going to kind of put all that together and describe how we do transformations or perform a transformation on a figure. Okay, so we're going to take this figure and we're going to transform it. So first we're going to draw the transformations right there, problem number 1. So here we go. So this tells me what the dilation is. And this tells me how I'm going to rotate it. So D stands for dilation. That's why there's D. So we're going to do it by 1.5. And then we're also going to rotate it about the y-axis. So first the dilation you usually want to do last after you move up and down, flip-flop, and then we dilate. Okay, so I want to rotate first. So the first step is to go ahead and rotate. We want to find the vertices, the corners, E, F, and D. By rotating. So we want to rotate about the y-axis. So that means I'm flipping it, folding it about this line right here. So y-axis of this triangle, D, E, and F. Then we just apply that rotation to each vertice or each angle there, or point, coordinates. So we're going to rotate D. We're going to flip it over that y-axis. So D is 2, 0. So when I flip it about the y, all that's going to change is my y value is going to come over here. So my y value is actually the same. The only thing that is actually going to change is my x value. So it goes from, I think this is counted by 2's, maybe. Nope, that's 1. So actually, D's right here. Come on now. There we go, as that 2. So 2, 0. We're going to go ahead and bring that over here. So it's -2. So when I apply that, I'll write it like this. So when I apply this rotation about the y-axis, that'd be D prime, our image, right? -2, 0. Then I do the same thing to all the other ones. Let's do E. So we know E is 1, 4. So E prime, or E, even though I wrote D. Jeez, killing me. -1, 4. So the y value stays the same when we rotate about the y-axis. The y value stays the same. Okay, final one. Rotate about the y-axis. We're going to rotate F. So we get F prime, or the image, right? So that'd be -4, 2. And then we can go ahead and graph those. -2, -2, 4. E would be -1, or that's, sorry, right there is E prime. D would be down here, right here, D prime, and then F prime would be at 4, but it's opposite, so -4 and up 2, right there. So that is folding it about the y-axis. Okay, and then we have a dilation of 1.5. So now we're going to take all these and we're going to multiply them. So I'm going to take these and multiply them by my scale factor. So that's going to be, since I'm changing again, I'm going to do double prime, 2 apostrophes. So now I'm going to multiply those by my scale factor, which is 1.5. So I'm going to take that and multiply it by 1.5. So I get -3, 0. And then E prime, multiply these two numbers, -1 and 4, by 1.5, and I get -1.5 and 6. And then for f prime is going to be multiplied by 1.5, so f double prime is negative 6, 3. Okay, so you want to do the flipping first and then do the dilation. So the dilation is always last. So here we have negative 3, and 0, negative 3, and 0. Then we have 1.5, negative 1.5, and 6. That's about right there. And then negative 6, 3. 1, 2, 3. So there's my final image. And that would be E double prime, because I did two transformations. I did a transformation and then a dilation, so I did two things to it. So there's your answer. This video seems a little long, but here you go. You're doing the same things. This one's kind of a little bit easier. You're going to move it 4 units to the right. So moving right and left deals with your x's. So all you do is add 4 to these x's, negative 4, negative 3, negative 1. And then up 2 units, well, up and down deals with your y's. So then you're going to add 2 because I'm going up. So I'm going to add 2 to all these. If I moved left, it would be subtracting. If I move down, it would be subtracting as well. And then after you do that to these numbers, you're going to get 6 new numbers, right? 2 for each one. And then you're going to multiply each by 1.5. So go ahead and try that. 6 minutes, sorry, apologize.